This video series is designed to inform the viewer of the theoretical and practical experiences and innumerable variables that come with designing with polymers and other substrates in a vast number of materials, end-use applications, and plastic conversion processes. In this video, we'll introduce the integrity of bonds in laminated constructions. We'll be discussing the challenges in choosing the correct materials, understanding what your bonds will confront in the field, creating a strong process, knowing that your product will endure, and more. Experience has taught Bixby that success of development programs often depends on the integrity of bonds in laminated constructions.
The approach taken by OEMs and extruders, laminators, without the capabilities of Bixby is to select each individual layer on its own, trying to fulfill the end-use requirement. The selections of each layer that you're going to use in your product will dictate what glues, adhesives, or tie layers are needed to make that product successful. As simple as that sounds, picking an individual glue and a layer to meet an end use, it gets very complicated because each layer is available from dozens of suppliers. It's available in dozens of different chemistries. There's different gauges and functionality to each layer. It's important when you're choosing a foam that's going to go with an elastomer that they're not fighting against each other. So understanding the end use and the raw materials available to meet the needs of the end use is critical. And as important is making sure the adhesives or the tie layers you're going to use to make that laminate function as a whole, the choice of those adhesives needs to match the properties and the functionality of each layer to be successful. Therefore, each component layer and their chemistries and the adhesives and tie layers used need to be optimized from a number of vendors. All of those variables in tie layers and functional layers makes a very simple process much more complicated. So it makes a lot of sense to bring all of those specification and engineering requirements. You're making all those decisions under one roof, managing all of those relationships.
The integrity of a laminate bond long-term also can be put at risk by the downstream physical, functional, and environmental requirements of the application.
All too often, a bond generated in the lab in a controlled environment is a good, strong bond. But in reality, that bond's exposed to chemicals in the environment, it's exposed to moisture, temperature, sometimes cycling temperature, impact. All of these things really dictate how good your bond is. So while you might get a good bond in the lab, it can fail in months, weeks, even days if it's not engineered for the ultimate end-use environment. This underscores the importance of working with folks who understand how a product is used, what the end-use environment looks like, what the temps will be, folks who can work with the vendors on each component to make sure it's suitable for the end-use environment.
Extrusion lamination is at the heart of Bixby's process. The company's success stems from the fact that it has relationships with many dozens of material suppliers and their technical experts. This enables Bixby to choose and formulate, if necessary, the core thermoplastics, hot melt polymers, additives, and superstrate and substrate materials to assure compatibility with a laminate system. Moreover, Bixby's process enables it to gain a thermal melt bond in process, often without the need for additional adhesive chemistries.
This is achieved by extruding molten polymers between functional layers, whether that's foam or reinforcement or our extruded web. If any of the functional layers are found to be incompatible, so the foam isn't bonding well to the extruded substrate, Bixby can modify the tie layer chemistry by taking two different compounds or additives to make that tie layer compatible to both the superstrate and substrate. Additionally, you could surface treat any of the superstrates or substrates being used. So you could take your foam and corona treat that foam to give yourself more surface energy to improve the bond. Similarly, you can use primers. So you could coat a primer onto one surface, making it more compatible with a tie layer, or directly extrudable with a functional layer that Bixby would extrude, whether that be a urethane or a polyamide. This is crucial because anyone who's worked trying to bond laminate layers together understands that getting good wet out is critical to ensuring a good long-term durable bond.
Functional material interface layer chemistries and the proper tie layer for those play a key role in achieving optimum bond strength. It often comes down to hot melt chemistries, which is why it's crucial to choose the correct materials. However, this phase of the process, like much of everything that has preceded it, is not cut and dry.
There's many hot melt chemistries available from many different vendors in many different chemistries. But there's also another alternative when you're trying to optimize your tie layer in a laminate construction.
Bixby not only knows and works daily with a myriad of commercial hot melt chemistries, it also formulates its own hot melts for custom applications.
By putting color, conductivity, or UV blockers into the tie layer to give additional functionality to the laminate.
The extrusion lamination process and hot melt chemistries are just two components that are carefully considered by Bixby's R&D team. However, to deliver innovative product solutions, the team must also make sure that these two elements are in sync with the client's end-use processes.
Some of the variables that have to be taken into account to ensure a good bond in the final application is what happens to the bond after we're done making that laminate. First, we need to recognize that the bond strength right after processing is usually at its lowest. Bond strength grows with time. Variables like thickness, temperature, pressure, exposure to different chemicals will all affect bond in the long run. In addition, post-process is conducted on the laminate to fabricate a final product such as thermoforming, cutting, and sewing can also compromise an application's ultimate bond strength. It is critical to select and test the tie layers and the interactions of all substrates used in a laminate for performance in the same mode in which the product will ultimately be used.
Success of the end product depends on the attention to the details of constructing a laminate, from selection, processing, and assembly, all the way through to designing for the final product's use environment. They also underscore why it's so important to partner with a company like Bixby International, the custom thermoplastic sheet extruder and laminator with more than 140 years of knowledge and experience. The next video in our series will take an in-depth look at tie layer chemistry. This and other videos will be available for viewing in our video library at bixbyintl.com.